In the 19th century, Charles Darwin deduced the basic rules that explained why living beings are different and why some impose themselves on others. Essentially, the variety among species is owed to mutations and small physiological changes that originate in reproduction. Over time, when this small change is beneficial for the individual, it may accentuate and become a distinctive feature, marking a different path of evolution. Thus, bird wings could have come about as a small protuberance, which originally may have served for jumping a little higher or for moving a little faster. With time, this incipient extremity turned into such a big advantage that it ended up as a wing for flying. The survival of some species and the disappearance of others was what Darwin called natural selection. He referred to the ability of fitting into the environment that each individual had to confront with every new experiment of nature. In this way, from generation to generation, through hundreds of millions of stages and periods, the stronger living beings, or those with a stronger ability to fit into the environment, triumphed over those that could not.
I don't have much doubt that most evolution occurs by small steps. There's a very obvious reason for that. If you make a large change to an organism, it'll almost certainly be bad. If you take a hammer and you hit the engine of your motor car very hard, it's most unlikely to do it any good. Big changes are, on the whole, big changes in a thing which is already extremely complicated and very efficient are likely to be bad. But it is possible that a small fraction, anyway, of the small changes that happen, just slight changes in shape or size, will be an advantage. And I think almost all evolution happens by these small changes. Having said that, there are some changes that it's rather hard to imagine happening in a lot of small steps. When we look back on evolution, we can point to one or two things that do seem to have been fairly dramatic and sudden. I mean, you were either one cell or two. I mean, you can't be 1.5 cell or 1 1/10 of a cell. So the origin of organisms which have many cells didn't happen very gradually.
The slow path traveled during the evolution of species is similar to a chronicle of failures. Most of the genetic variations that a species undergoes do not provide an advantage. And although the factory of biodiversity doesn't stop generating new types of species, in reality, few are able to find a place in nature. The biggest enemy of survival, however, is not found in the individual's difficulty to evolve, but in the catastrophes that with a certain frequency have really shaken the earth. Like a strong blow of an axe at the tree of life, every cataclysm has provoked the sudden disappearance of most of the species that would have conquered the earth at a certain time. The scars of dozens of environmental catastrophes are found in the geological registry. We know that 5 of these catastrophes produced massive extinctions. There are 3 in particular, however, in which biodiversity suffered major destruction. The first great extinction took place 440 million years ago, during the Ordovician period. It caused more than half the species to disappear. This was the end of the first phase of life diversification, and investigators believe that this was the consequence of an enormous freeze of the Earth's climate. 200 million years later, during the Permian period, the most deadly of all known extinctions occurred. 54% of the families and 96% of the marine species were driven out, thus destroying the biological factory of the oceans. The trilobites disappeared, just like many insects and all the coral from that time period. This extinction, however, determined a new diversity, in which terra firma would become a new element. It would not be long before the dinosaurs arrived. Finally, 65 million years ago, the extinction best known to man occurred. The Cretaceous period, in which the dinosaurs disappeared, opened the way for the mammals to find the road for their diversification and mastery of the Earth. Geologists and biologists explain that most of these extinctions are due to climate changes that altered environmental conditions. The motive was occasionally the crashing of meteorites and asteroids coming from space, their impact being similar to hundreds of nuclear bombs falling on the Earth.
Well, we can think about the candidates for this biological destruction, and there are really only 3 or 4 that have been proposed seriously in recent years. In many ways, the favorite candidate of most people is a bombardment by a very large meteorite. We know that happened 65 million years ago at another time of great extinctions, the time when the dinosaurs were wiped out. On the other hand, there is only very limited and controversial evidence for any kind of meteorite impact at the end of the Permian. Other things that have been proposed are large-scale drops in the sea level, large changes in temperature. Neither one of those actually seems to solve our problems. But there's one more thing that happens at the end of the Permian that makes a lot of people think, and that is one of the largest volcanic events that we know of in the last 500 million years happens precisely at the end of the Permian, when almost the entirety of central Siberia was covered by up to 1 kilometer of lava. This kind of very large volcanic event might well trigger other kinds of events in the oceans and atmospheres. And so it's at least possible that this particular extinction was triggered not by something from outside the planet, but something from inside the planet.
The process of extinction would normally begin because of major contamination. Meteorites or volcanoes would shake and move the Earth's surface, and as a result, chemical substances would be lifted from the Earth's crust into the atmosphere. Among these substances, carbon dioxide, the gas that is generated today when oil is burned, was very toxic due to its high concentrations, and few species were able to tolerate it. These clouds of dust and gas became so dense that they acted like the windows of a greenhouse. The Earth reheated, ice melted, and water cycles were modified. Hydrological regularity at that time was substituted by unexpected floods and fierce droughts. The plants suffered highly from such aggression. As time passed, there were fewer plants to absorb carbon dioxide and let off oxygen. This process is known as photosynthesis, which so many living beings depend on for breathing. Thus, little by little, contamination spread like an oil slick. The species could not defend themselves and couldn't survive. They didn't have enough time to try to adapt. After a major extinction, life was left in the hands of a few survivors. They marked the guidelines for the kind of species that would continue to inhabit the Earth. And as a consequence of such great biological catastrophes, the same forms of manifestations of life were never seen again.
The general pattern is